Good morning class 12 students. So this is your subject physics, chapter number 13, that is nucleus. So as I told you, your chapter was completed yesterday. So today I'll be discussing some NCERT solutions, and because most of the syllabus of this chapter was removed from the syllabus, so I'll be telling you first of all those questions which are removed, so you do not have to perform those questions. Okay. So this is the list of questions which you do not have to do. That is question number 6 to 10, 12 to 19, 22, 25, 26 and question number 27 to 30. These all questions are from those topics which are being removed from your syllabus. So you don't have to do these. Okay. So cut them. So now I'll be discussing question number 1. Okay, so now question number 1 says, A part says, two stable isotopes of lithium-6 and lithium-7 have respective abundances of 7.5% and 92.5%. These isotopes have masses 6U and 7U respectively. Find the atomic weight of lithium. Okay, so here you are given the isotopes and their masses, and you are given their abundance. So if such thing is given to you, then the formula to calculate atomic weight is mass of first particle into abundance of first particle plus mass of second particle into abundance of second particle upon total abundance. So this is the formula that we will be using here. So now because mass and abundance percentage is given to you, and one more thing, just keep here the abundance in percentage only. That will be the formula. Okay. So therefore, first of all, mass of lithium-6, that is 6.01512 into abundance of lithium-6, that is 7.5 plus mass of lithium-7, that is 7.01600 into your abundance of lithium-7, that is given to be 92.5% upon total abundance, that will always be 100 obviously. So when you will calculate it, the answer will come to be 6U. And one more thing, this U is nothing but atomic mass unit, because here the masses are given in atomic mass unit. So your final answer will also come to be in atomic mass unit. And this, when you calculate your atomic weight using this formula, that is also called weighted average. Okay. Okay, so the B part of the question says, boron has two stable isotopes B10 and B11. Their respective masses are 10 and 11U respectively, and the atomic weight of boron is 10U. Find the abundances of B10 and B11. So here just opposite thing is there. You are given the atomic weight and you have to calculate their abundance. So again, let us first of all suppose that abundance of B10 is X%, and because total abundance is 100%, so therefore abundance of B11 will become 100 minus X%. Now by using the formula of atomic weight, so atomic weight is given to be 10.811U. So this will be atomic weight, which will be equal to mass of B10, that is 10.01 into its abundance, that is X, plus mass of B11, that is 11, into your abundance percentage of B11, which is 100 minus X. And as I told you, total abundance is always 100, so that will be upon 100. Okay, so when you will solve it, the total abundance for B10 will come to be 20%. And if X is 20%, that means 100 minus X will be 80%. So total abundance for B11 will come to be 80%. Okay, so question number 2 is the simple question as we did above. So do that question. Now question number 3 and 4. Okay, so if I tell you any one of the question, you will be able to do the second question yourself. So I'll be explaining question number 4 to you. Okay. In question number 4, it is given, obtain the binding energy of the nuclei Fe36 and Bi209 in units of mega electron volt from the given data. Okay, so as you have studied in your theory lectures, to calculate your binding energy, first of all we have to calculate mass defect. So here also, first of all, we will be calculating mass defect. So now if you remember, the formula of mass defect is number of protons into mass of one proton plus number of neutrons into mass of one neutron minus mass of nucleus. So I will show you how to calculate binding energy of iron. Then for Bi you can calculate it yourself by using the same method. Okay, so now if you clearly see, this is iron, which has an atomic number of 26 and mass number of 56. Okay, so now as you know, atomic number is nothing but number of protons and mass number is nothing but number of protons plus number of neutrons, or you can say number of nucleons. So if you want to calculate binding energy per nucleon for this, first of all we will be calculating mass defect. So number of protons, that is Z, which is 26. So therefore 26 into mass of one proton, that I am taking into be the units of U, that is atomic mass unit, and that is 1.007 plus A minus Z, that is number of neutrons, which will be 56 minus 26 here. Okay, into mass of neutron, which is around 1.008 U, minus mass of nucleus, which is given to you in question, that is 55.9 something. That okay, now I have put their mass in the atomic mass unit because the mass of nucleus was given to you in the question in that form only, in atomic mass unit. Okay, so now just you have to solve it. This will become 26.2 plus 30.2 minus 55.9. So when you will solve it, it will be 56.4 minus 55.9. So that will come to be 0.5 AMU. So that means the atomic mass, the mass defect for the iron element is 0.5 atomic mass unit. Now if you remember, yesterday in theory lecture you have calculated that if mass defect is 1 U, that is 1 atomic mass unit, your binding energy was coming to be 931.5 mega electron volts. So now if del M is 1 atomic mass unit, binding energy is 931.5 mega electron volt. So now here we have to calculate binding energy for 0.5 AMU. So just multiply 931.5 by 0.5. So for 1 AMU, your binding energy is this much. So binding energy for 0.5 AMU will be 0.5 into 931.5 mega electron volts. So when you will solve it, the answer will come to be around 492 mega electron volts. So this is the binding energy for iron element. Now in the question you are asked to calculate binding energy per nucleon, because it is asking which element has greater binding energy per nucleon. So if binding energy of total nucleons is this much, binding energy per nucleon will be total binding energy upon total number of nucleons, which is 26 plus 30, because 26 is number of protons and 30 is number of neutrons. So when you will solve it, that will come to be around 8 mega electron volts. So I have calculated binding energy per nucleon for Fe. Now you can easily calculate by same method binding energy per nucleon for Bi, and then you can compare which one is larger and which one is smaller. Okay, so generally you will see that iron will be having a greater binding energy per nucleon as compared to bismuth. So in the further questions, in mostly all the questions, you have to calculate binding energy per nucleon or binding energy. So use the same method and calculate binding energy. Okay. Thank you.